Today we're going to evaluate expressions. In our notes we have three functions. F of x equals 1 over x squared. G of x equals x squared minus 2x plus 2. H of x equals x minus 2. And k of x is equal to the square root of x minus 1. Four expressions. So let's take a look at our first example. We'll do this first one. A, f minus g of negative 1. You might remember that means f of negative 1 minus g of negative 1. Okay? And you might remember that f of negative 1, we simply substitute negative 1 in f of x. Since f of x is 1 over x squared, this means 1 over negative 1 squared. And 1 over negative 1 squared becomes 1 over 1, which becomes 1. G of negative 1 means substitute negative 1 in the expression of g of x, which is, we should put all this in parentheses, negative 1 squared, because it's x squared, so it's substituting negative 1 into x squared, so it's negative 1 squared minus 2 times negative 1 plus 2. And we have negative 1 squared is 1. 2 times negative 1 is negative 2 plus 2. And we get 1 minus a negative 2. That's the same as 1 plus 2. So we get 1 minus 1 plus 2 plus 2, which would be equal to minus a 5. And finally we get minus 5. And 1 minus 5 is equal to negative 4. Our second problem is g over h of 2. That means the same as g of 2 divided by h of 2. And g of 2 means we substitute 2 for every x in g of x. So therefore you get 2 squared, because it's x squared, minus 2 times 2 instead of 2 times x, plus 2, that's in the numerator. And the denominator, h of 2, and I do have a mistake here. I should fix that. In fact, it's all fixed. So h of 2 is equal to x minus 2. So we substitute 2 for x, and we get 2 minus 2. And trying to simplify that, the numerator becomes 4 minus 4 plus 2 over 2 minus 2, which is 0. We know that we cannot have a 0 in the denominator, and therefore this function is undefined. And we're done. Undefined. Any fraction with a 0 in the denominator is considered to be undefined because of the 0 in the denominator, and that is the end of that problem. Our next problem is h times f of x. So basically that's the same thing as saying h of x times f of x. We know h of x is x minus 2. We know f of x is 1 over x squared. If we multiply this together, we get x minus 2 in the numerator, because x minus 2 times 1 is 1. You can think of x minus 2 as x minus 2 over 1. Denominator, we get 1 times x squared, which is x squared. And that can't be simplified, and that is our final answer. Our next problem, k circle h of x. This is a composition of functions, which means k of h of x. We know that always do the parentheses first, so we know h of x is x minus 2. So that gives us k of x minus 2, because that's what h of x is equal to. Now, the rule for k of x says find the square root of everything in the parentheses and then subtract 1. So k of x says find the square root and whatever is in parentheses, which is our x minus 2. And from that, the rule says subtract 1, because k of x is the square root of x minus 1. And x minus 2 minus 1 becomes the square root of x minus 3. And we are done.